Hi, I'm Paul from Test Data Services, and this video is focusing on X-Ray. It's a really deep dive. So it's a deep dive into using X-Ray for extracting instrumentation data and then merging it in with test results so that you can do some sensible analysis. The analysis that I'm showing here is in Grafana, and all of the data from the load test, that's from Load Runner Developer Edition, and from the actual X-ray traces themselves are being sent to InfluxDB and they're being displayed with Grafana. So the video is going to go through the approach to extracting. I'm going to walk you through the code that I'm using to do the actual extract of X-ray traces and segments, and then form those segments and even subsegments into transactions that get sent to InfluxDB. I'm going to show you how that works. I'll include the code below so you can actually copy and paste this into your own environment and it will run. It's not perfect code, it's a proof of concept, but it might be a starting point for you. I'm also then going to show you some traces and some of the nuances with some of the actual traces. X-ray is fantastic, but there's a little bit more to it than first meets the eye, and it's really important if you're trying to troubleshoot performance issues that you have an understanding. So I'm hoping this video will give you that basic understanding. So the first thing I might do is I might just show you a few of these traces. So in a test, I might, let's grab a trace here. I might have this trace. So this has got a few components in it, and we've got everything coming in, or the initial calls coming in from an API endpoint in API gateway, and it goes through to Lambda, fires the Lambda function, and then the Lambda function does a whole lot of DynamoDB calls. And I've actually put some custom tracing in here for how long does it take to create keys and how long does it take to sign a JOT, an OpenID Connect JOT. So to give you an idea of what that is, I'll quickly just go through to the actual call that was running that produced that trace, that Lambda function itself. So this is that Lambda function. In the beginning of this Lambda function, I just have to have these two lines. This is Node.js 12.x. These two lines will basically activate all of the X-ray. Normally, you might just say require AWS SDK. Instead of that, if you put the X-ray code instead, then it will actually capture all of the calls. So all of DynamoDB calls or SQS or S3 or whatever will all get captured and you'll see them in that trace like what I just showed you. But for extra calls, if I just zoom down here, I have some special segments. So I've put a segment in here and I've called it JWT crypto. So basically I'm adding a new segment and I'll put start and end indicators or markers around it so that in the actual trace itself, I'll be able to see JWT crypto is 9 milliseconds. Now, when I'm plotting that on a graph back here to our original, we can actually see that as a separate transaction. The crypto, sorry, I've called it crypto here, not JWT. So you can see here that we had a few slow ones. We had 23 milliseconds. We had 33 milliseconds. So we've got some slightly slow-ish ones. And that would be 100 milliseconds, 0.1 of a second up here. So we can see there's a bit of variation. So basically, by having that instrumentation in your code, you don't have to put it in there, but if you do, you can get really fine granular detail and you can visualize it, which is, I reckon, pretty nice. If you use the actual console itself, the AWS console, you get a lot of fantastic information, but you get to see it in a particular slice. You might see it in a 15-minute period of time. You'll see this service map. You'll be able to zoom in on transactions that conform to some component of the response distribution, which is fantastic. But if you want to see it in the time domain and see segments themselves, you really need to get the data out of X-Ray to do it, and that's what this video is about. So that's a quick walkthrough of the underlying environment that we're working in. So now to go back to this call that extracts the traces. So what this is doing is it's going in and the call is accepting this payload. This is the event. It's getting up to 6 parameters, a lookback seconds and a window seconds. Window, as you'd imagine, is how many seconds am I going to consider the traces to be able to inspect them and then maybe turn them into transactions in InfluxDB. And this is how far back do I look. Now, the reason for this is quite often it takes about 10 seconds from when a Lambda function finishes to when the trace is available. And we don't want to fetch traces that are incomplete, because if we do that, we'll then record them twice, possibly one in an incomplete state and one in a complete state. I found that if I leave a 20-second gap, I won't get incomplete ones that unless there's a problem with them, which occasionally happens. So if we have a look here, this is looking back 80 seconds and it's giving us 60 seconds of trace data to the most recent 20-second point. If we call this every 20 seconds or so, that means we'll probably have 2 or 3 times of attempting to catch every point, which I think is a good way to do it. If you run very, very hard with very high volumes, you might hit limits occasionally just by even moving around in the AWS X-Ray console where you exceed the limit of X-Ray requests you can do. That's happened to me a few times. So to cover that, I just hit it a bit harder, which I know is counterintuitive. The other thing we do in here is I've got this target entry point, is what I labeled it. Whatever this text is in here, it will only produce data and send it to InfluxDB if this string is in the name of the segment, the name of the trace to be considered. This is the threshold. It'll ignore everything that's less than this. And this, you can ignore that one, I've taken that out. And this is the host for where to send the InfluxDB messages to. What the script is actually doing, or the Lambda code is doing, and you can copy this yourself into your own Lambda and run it, and it will run. It basically separates into 2 parts. The first part gets X-ray trace summaries, and it needs to do this in a loop because it needs to have a look at the next records. If it returns, 3 million records, it can't give you 3 million records at once. It will give probably 500 or 600 or 700 records. So it has to do it in a loop. This is that looping process. One of the things that we're doing in here is looking at the name, and we're doing this if statement here. If the trace summary endpoint name includes that event target entry point, consider it. But basically what we're doing here is we're pushing that trace ID into a structure. Then we look at every one of those trace IDs and we go through and process them. So for each of these trace IDs, we have to do this getBatchTraces call, which brings back the entire trace. Now, what this trace actually is, if I go to that trace I showed you before in the AWS X-Ray screen, you can see this is its visual representation, and that's the timeline tab. If you click on raw data, this is the actual data that the trace is made up of. So you can see that it actually has quite a lot of data in it. It takes a little bit of effort to figure out which of this information should go into what transactions. So that's why my code might look a bit on the convoluted side. It works, but it may not work for everyone. So just use it as a starting point if you choose to. You can see in here it says duration. There's a start time and an end time. If the transaction is not finished yet, end time will be missing. If the transaction timed out, like if you've got a 3-second limit and the DynamoDB was going to take 3.1 seconds, you've obviously blown your limit. X-Ray won't even be able to capture those remaining segments. They'll just be missing, and you'll end up not having an end time because there was no end event because the Lambda was terminated before it had a chance to end. They're the sorts of issues that you might find on the first pass through. So when you do this for the first time, You might find you've got dodgy X-ray data. You might need to tweak things to get better X-ray data. But in the process of tweaking to get better data, your app will actually work better. So it's actually a good outcome. So back to the actual Lambda function that extracts everything. So we do this call. That then gives us an X-ray trace details. We then have to step through all of the segments in that. I just showed you what they look like, and I'm doing a whole lot of things in here which give you information that you don't actually get from that screen. So if I go back to here, I can see these subsegments. They've each got an ID, and then there's subsegments within subsegments, and they've got start times and end times. If we look at this on the timeline view, we can see that it's lined everything up, and it's used those start and end times. And in this case, everything sort of matches, which is good. And if we zoom in a bit, if we click on this here, because that's a slow call, we get all this extra information. Now, this extra information is in one of those sub segments. So I need to look at those and work out what bits I need to populate the database. But the things that don't appear in explicitly in the data is the gaps between these times. So in this one, there's not much of a gap. You can see it's 1.1 seconds, 1.1 seconds, and 1.1 seconds. But on some calls, you might see something like this, where the API endpoint recorded 0.8 of a second, but the authorized call from a Lambda perspective took 794 milliseconds, but the actual initialization here took nearly 400, and the actual execution or the invocation took 250 or 244, but there's a gap here. So what I'm doing in this code is I'm also looking for unaccounted for time. Oops, wrong one. So I'm doing a bit of math, a bit of logic, and if unaccounted duration is more than 5 milliseconds, then I'm logging it. So what I'm also doing is for every single subsegment that I'm interested in or extra thing that I'm interested in, I'm recording 2 transactions. One of them is the value start and one's value end. Now, the reason for this is in a time series database, we will have everything recorded according to time. What I'm doing is I'm putting the value start as a response time or a duration, but the time I'm using is, in this case, the start time versus the end time. This min and max is where I've had to calculate things and not use the actual numbers. So after I make all these calls to add metrics for the start and end points, well, those calls go down to here to add metric, and they basically add into a buffer, a large buffer, and that large buffer, when it's big enough, will go to post metrics, and it will actually send a whole chunk. The reason for that is we don't want to send 5,000 little tiny transactions through to InfluxDB. We'd rather send 5 with 1,000 in each. So what I'm going to do now is I'm going to actually show it to you when it's running, so you get a good idea of what's happening. So I'm just starting everything up for that. But before I do, there's 2 other traces I wanted to show you. This trace here, oh no, I showed you that one already. This trace here shows pending, and then it hasn't got any information hardly down here. In this one, what happened was very similar to this one, where we had a DynamoDB call, but instead of it taking 1 second, it took more than the maximum time for that function, and the transaction didn't end. So in this one, it says pending here, but the actual raw data, it's just missing that end time, like I mentioned before. So the code in this Lambda function needs to cope with that missing end time and do something smart and sensible, and it does. So that's good. So what I'm doing now is I'm running a little bit of activity. I'm going to change this to the last 5 minutes, set it to 5-second refresh, and I'm going to show this running to you live. So I've got some transactions running through, which we should see. Okay, so we're now running some activity, and we've got two transactions coming through. These purple ones, which is the authorized call, and the yellow ones, which is a push identity call. I've only set up this export function. Well, I've actually set it up to do everything, but what I'm going to show you now is just the authorize. So if I show you configure events, you can see where we've got authorized. We're looking back 3 minutes, and we'll bring back almost 3 minutes worth of data. So if I hit the test button now and then flip back to the view, we'll actually see some of these traces coming through. There we go. You can see some traces. Now, let's have a look at what the threshold was. Go back to the threshold. Sorry, this one. Configure events. 0.1. 0.1's a bit low. Let's make this 0.25. We don't want to get too much data. If we get too much data, it's a bit on the useless side. We want to use the filter to give us just the data that we really care about. I didn't need to save. Now I'm waiting for that previous run to run. While I'm waiting, I'm going to show you sampling just so you can see what we're doing. So at the moment we're doing 184 traces per second. So if we're looking at over 100 traces, that means we're looking at like 18,000 traces. So it's a decent number of traces, and each trace that satisfies the criteria is going to fire a stack of transactions into InfluxDB. Let's see how we're going. So it's finished running. It ran for 54 seconds and it generated 57,000 data points for InfluxDB. That's because I'd set it at only 0.1 seconds. If I changed it like I just did to 0.25, it'll run much faster, 44 segments. So that's more useful. Let's have a look at the difference. So we had a whole stack of transactions in here. And now we'll just have the odd one. Maybe some of those were duplicates over there. Maybe, yeah, they probably were. So if I run that again, maybe I'll change it so it's say 0.2 seconds instead of 0.25, just so I can get some information out. So we've got 252. You can see that's pretty quick, right? It's a pretty neat transaction to run. And so we can see if I click on them, initialization, we haven't really got any in the current time frame. Invocation, crypto, we had a couple of slow ones here. Complete time, unaccounted for time, unaccounted for from an API perspective, and all of it. So here we go. We can see a few here and a few here. Not particularly many, and that's okay. That's what we're supposed to get. We just want to get selectively the number of transactions we're interested in. When you saw 254 data points or entries for InfluxDB, and we only see a few dots here, it's because I'm not actually graphing everything. So you've seen now the transactions coming through. You've seen some traces coming through. The other thing I wanted to show you for debugging in this code is I actually set it up so I can have specific traces as well. So if I show you what that looks like, specific trace, you can put a trace ID in, and then if you do that, let's just make this 0.51 so that we won't fetch any data. We'll just, from the current activity, or probably won't fetch any data, we'll just get the trace information. You can see in here I've got some log, and it will show us that for that particular trace, which we could then look at with X-Ray. In fact, I'll do that so you can see what that looks like. Test, configure, take the trace ID like this, copy, and we just go to X-Ray, and we just paste the trace in like this, and then we get the trace. So we can see that this trace here is the one that we just got back, which is this one. And these are all of the components. So the transaction is TD ORDC authorized, and then the component is invocation, and the resource is undefined, or the resource is TD 001 or 0001F ODC client ID. So if we do a get item in DynamoDB on this particular table, that's how we can plot that. If we do an update item on this table, that's how we can plot it. If we do a batch get item on all of these tables, they're all listed. So basically, you can see every single subsegment and quite often sub-subsegments, and you can turn one trace into, in this case, 24 transactions. Oh, I nearly forgot. I'd like to just show this to you as well. The initialization is when Lambda cold starts. If we look at all of the transactions, we can see that we had 1, 2, 3, 4, 5, 6 bursts in this period of time. By looking at the initialization component or segment, we can actually see that we had a small number of initializations at the beginning of each one. Now, what I've noticed is when I'm running tests that ramp up to very high load, I'll get a second, third, fourth burst of those as new infrastructure is pulled in. So I think that's pretty cool as well. It's a way to visually see when a bunch of your transactions that are slow just because of Lambda cold starts. I think that's pretty great. This is the invocation time, so the actual runtime, and compared with the initialization time. So I think that's pretty good too. Hope you found this useful and interesting, and give it a go, and let me know in the comments what you think. I know it's a fairly deep dive. Hope I haven't gone through too quick. You can just rewind if you need to. And all the best in your X-raying and performance engineering and troubleshooting. Have a great day.